Alright, so a couple of demos. The first one, we're gonna kind of do a review on inheritance, and we're gonna, of course, add the interfaces and abstract classes to it. And the second one is gonna look fairly similar to what the assignment would look like. So let's get to it. First off, I'm gonna create a new class, and that will be my bank account class. Alright, so as we said, any bank account would have a string that will be the account number, and we're also gonna have a double, which is gonna be the balance. Let's create some getters and setters and constructors. So I'll use the generate constructor. Fine, let's do both, and here we go. And let's create our getters and setters for both of them and hit OK. Now, once the bank account has been constructed or has been created, you really don't want anyone to just come in and modify the account number. So this setter here is really not needed, so we're gonna take it out. And the same goes for the balance. You don't want anyone to just call, hey, set my balance to $1 million. That's not how it works. So we're also gonna take that out. So we only have the getters for our class. And we're gonna need to have our own deposit and withdraw methods. Alright, so this looks like a basic class. Let's create our checking or saving account classes as well. This will extend my bank account. Here we go. I get an error that says, well, let's just create the constructor. Okay, so now I can construct a checking account based on my bank account. So maybe I want to modify my withdraw method to have some kind of a limit on how many times I can withdraw every month. So first off, I'm going to create those two properties here. I will have an int that is the withdraw limit, and I will have an int that is the withdraw count. In my constructor, I'm going to set these to zeros. Or actually, the limit will be maybe 10 times a month. And this dot withdraw count is 0. Alright, let's overwrite our withdraw method. So I'm gonna type in withdraw, and it will, this one is actually calling super.withdraw, which is just deducting the balance with that amount. So all I need to do here is I'm gonna say if my withdraw account is less than or equal this dot withdraw limit, then you may call that. Otherwise, do nothing. Alright, so here's our checking account. Let's go play around with it in the program. So I'm gonna instantiate a checking account. I'm gonna call it account1, and that will be a new checking account. I need to pass in the account number, which is gonna be QWERTY, and a balance, which right now I'm gonna say 1,000. All right, let's call system output, and let's get the account number one dot get balance. Perfect. Let's perform some kind of a withdrawal here or a deposit. So I'm gonna call account one dot deposit another 1,000, and let's call this again. Save it, run the application, and here's our output. Notice here that I can actually create a bank account object, and it would not throw any errors. But what we talked about is that there is almost never a case where you just want a bank account that does not have a type. So what we need to do here is to go back to our bank account class, and we're just gonna say that this is an abstract class. Oops, abstract class. Now if I go back to my program, you see that this is actually throwing an error saying that this cannot be instantiated, which is the behavior that we're expecting. All right, great. Let's create an interface now. So I'm going to go back to my source, create new Java class, and I'm going to change the type to an interface. I will call this printable. Here I'm just going to specify the method signatures that are part of the contract that any class implementing this interface will need to uphold. So I'm gonna have to have a public that will return a string, and I'm gonna call this print to string. I'm also gonna have another class or another method signature that will return void, and I will call this print to console. Let's first implement this interface on the car class that we had before. So if I go up to my class definition, I'm just gonna say implements printable. As soon as you do that, you get this error that says, well, you're signing this contract, but you're not really implementing all the methods that you should. So we can do it manually, or I can just go to this light bulb here and I do implement methods. And yes, do all of them. So these are valid implementation of these functions. This is returning null, which can be a string, or we can make it an empty string like that. And this is returning void, so there's nothing in there, and that's all right. But now we're gonna have to modify this implementation. And here's my implementation for the print to string. I used a little bit of ASCII art here, so you can make like a car shape. Now if I go to my program and let's create a car class. So I have a car, I will call it my car, and I'm just gonna use the default constructor. Now if I do system out and I do my car dot print to string and save that, let's comment this out, we don't need that. Save and run, and here's our print to string for our car. Now let's see the same thing with the bank accounts, and let's uncomment that for now, but I'll go to my bank account class and I'm gonna say this will also implement printable. Notice here that we didn't get the same error that we got on the car class, and that's because this is an abstract class, meaning that it doesn't necessarily have to have this method, but any class that will inherit from bank account will have to at least have them. So if I go to checking account, here I get my error. So here I have two options. I can either implement this at the bank account level, or I can do it at the subclasses or the child classes of the bank account. And I'm just gonna do it at the bank account here. And here's my implementation for the bank account. If I go back to my program and let's run kind of the same thing on the banks this time. Let's do system out account1 dot print to string, save that, and let's run our application. We first get the withdraw and deposit the first two system outs that we have, then we have the print to string for the account information, and then we have our car information here. So you notice that there were actually no common implementation between the how we printed the bank account information and the car information, and that's why it wouldn't really make sense to put the printable as a an abstract class. Also, because in Java you can only inherit one class, this would have been a problem for the checking account had we decided to implement the printable directly on that class, because then I would have been trying to inherit both the printable interface or the printable abstract class and the bank account class.